Good afternoon. I'm Courtney Carr, the Director of Marketing and Education for IAPD. Thank you for joining today's e-training webinar, Phenolic and Glass Cloth-Based Thermoset Materials, presented by Mark Mush of Atlas Fiber. During the presentation, you may submit questions into the Questions tab on your webinar toolbar, and we will answer them at the conclusion of the presentation. Following the webinar, you will receive a link to a survey. Once you've completed the survey, there will be a link to download the presentation slides. A recording of today's webinar will also be available for download on the IAPD website. Mark Mush is the National Sales Manager for Atlas Fiber, and he's been with the company since 2010. His over 25 years of experience in the plastics industry include distribution, machine shop, and manufacturing expertise. I would now like to turn the presentation over to Mark.
Thank you, Courtney, and we definitely appreciate IAPD allowing Atlas Fiber to make this presentation today. Typically, our presentations last 30 to 35 minutes, and I really plan on spending no more time than that today. And of course, we'll be glad to answer any questions at the end of that. So today's discussion, we're going to basically cover a few points here. We'll give you a brief intro to Atlas Fiber, kind of an overall market perspective of what thermosets go into, the technical properties of the materials, glass-based materials, phenolic materials, and the three shapes that they come in: sheet, rod, and tube, and then fabrication. And then important to keep in mind throughout the whole presentation, I'll be trying to do specific examples of different applications for the different materials that are out there. So really, Atlas Fiber in brief, we're 60 years old, celebrating our 60th anniversary this year. We are ISO 9001 certified. We also do have ITAR registration. If you have military or aerospace customers, they typically require that. We've been in our 117,000 square foot facility for almost 3.5 years now. And we do have the largest inventory of laminate sheet and rod in the United States, actually in all of North America. And we are the world's largest manufacturer and inventor of ground sheet rod, which I'll explain in a little bit. So the marketplace for thermosets. Well, thermoset materials like G10 and Phenolic, they're typically used where electrical or thermal insulation is required or in structural parts. They can be found in many, many industries. And if you start in the upper right-hand corner there with machine shops, farm equipment, knife handles, missile and aerospace, as you get to the bottom there, you have MRI equipment, transportation, satellites, and then as we move clockwise, nuclear power, power transmission, aircraft carriers, anything with electrical panels, electrical equipment. The tank there, obviously a defense-related project, and then steel mills, and then finally semiconductor equipment with a nice picture of some G10 there in a semiconductor application. And really, all of our materials start out with the NEMA and mil spec callouts. NEMA stands for National Electrical Manufacturers Association, which is the governing body of our materials. And from left to right, you see the NEMA grade, the mil spec, and then the type. And that also is the order of predominance. NEMA grades, probably 80 to 90% of the time, the customer will call you up with the NEMA grade. They'll say, I need some CE or LE or G3, for example. Occasionally, about 5 to 10% of the time, they'll come in with just the mil spec only, like a mil, and the governing mil spec there is mil I 24768, and then the slash dictates what the material is. So in this example here, the mil I 24768/18, that is G3, and somebody calls it, calls up that spec, they want the G3. And then on the right-hand side is the type. This one's seen very rarely. Sometimes you'll see a blueprint, and they'll just say type GPG, following our G3 example there, and then they want G3. So the NEMA sets the standards for materials in order them to be called NEMA grades. So what that means is, and I've got the G3 blocked out here, so each material has to meet a certain minimum, and the figures I have here aren't the minimums, they're just our typical data points. But if you look at tensile strength and compressive strength on G3, the tensile strength is 42,000 and then 76,000 for the compressive strength. If somebody were to manufacture a material and only test it out at a compressive strength of, say, 20,000 PSI, there's no way they can legitimately get around and call that G3. It has to meet certain NEMA specs. And again, this is just a partial list here. If you want more technical data, we do have our email addresses throughout the presentation. Feel free to send an email. We'll be glad to send out the full data sheets for you. Another aspect about our materials is they're very heavy materials. They're very dense materials. So this is a snip of our weight chart. And you can see the example here. I used phenolic sheet, a 1 inch 4x8 weighs 230 pounds. And then correspondingly, if it's 2 inches, it's doubled and it'll weigh 460 pounds. And then you notice that the FR4 weighs even more. So the same equivalent size sheet in FR4 versus phenolic weighs 320 pounds. A 2 inch sheet's going to weigh 640 pounds, and then so on. You can imagine as you get up to a 6 inch sheet, that's a pretty heavy sheet of material that we're dealing with. And then as far as chemical resistance, for the most part, again, a little snip of our chemical resistance chart. Many of our materials have some great chemical resistance capabilities, as well as their electrical and thermal properties. Again, a small snip here. If you'd like the larger version of this, just send me an email at the end of the presentation or at any time, and I'll be glad to get out to you. And then this is a slide that we've incorporated a couple years ago to have the little Three Stooges logo on the top, and it's entitled Common Errors Seen in Thermosets. And these are typical errors that we see, and sometimes they can have some pretty bad effects for you. Going left to right, the first one you see there is G10 phenolic. That's simply a material that doesn't exist. You're calling out two different materials. It's like calling out somebody calls you up and I want some nylon Delrin. It's a material that does not exist. So you have to be very careful about mixing up grades, certifications, and then I put G11 phenolic for Boeing. And what happened there is that we had a customer bought some material, they listed G11, but in their cert to their customer, they certified it as G11 phenolic. And you can imagine with Boeing, they just went absolutely ballistic on that. The material doesn't exist. So it, several conference calls later and a lot of clarification and fixing of the problem. So the main point is be very careful on how you call the materials. Next one over, the Thermoset hex rod, simply a material that does not exist. It does come in angles. They're not stock, but unlike GPO3, for example, there are no channels or anything like that. And then moving over to brand names, that's a picture of Leo Baekeland. He invented Bakelite back in 1907, so our material's been around for a long time. But the brand name point is like micarta or garolite. So sometimes a customer will call you up and say, I need some micarta. And what you need to do there is you need to drill down to more specifics. It's basically like asking what type of car you drive. And your response is, well, I drive a Ford. Well, what type of Ford? So if somebody's calling up and they need some micarta or they want some garolite, you have to ask them, hey, is this FR4? Is this phenolic? What is it? And then finally, old and outdated specs or material call-outs. I mentioned Bakelite before. That's a material that no longer exists, so that's sometimes used as a catch-all for our materials. You need to find out some more information about that. The MIL-P 15035 is simply a material that does not exist. That's been replaced by the MIL-I 24768. As with all of these, if you have any questions at any time in the future, feel free to call our office. We're more than glad to help you out so you don't make a mistake with the G11 for phenolic for Boeing, for example. And if I delay, that means I'm just grabbing a little sip of water here. So we have two types of materials. The first one is glass cloth-based materials, and this is your FR4 G10, G11, G9, G7, and G3. Those are all what we consider glass epoxies. And one note that we like to make about that on the left-hand side here is these are all examples of FR4, and the one that you're probably most familiar with is the one that's highlighted here, the second from your left. That's the natural color that you typically are experienced with. But colors in FR4, as with all of our materials, can vary from lot to lot, manufacturer to manufacturer. This is an extreme example, but the point is, if you ever have a customer that's very concerned about color appearances, let us know in advance because then we can order material and set it aside for you and to maintain that color consistency. So the first material, FR4/G10 glass epoxy. This is probably the first laminate material that most people hear about. It is by far our most popular material and most well-known. It's got great electrical characteristics. It's extremely high in mechanical strength. Temperature range goes up to 140 degrees C. And then you notice that the shelf life limitation on this product is 10 years. If you keep this inside, keep it away from the sun, it's not getting exposed to any elements, this material put on your shelf today will be good in 10 years. And that pretty much applies to all of our materials. Just keep them out of the sun, keep them out of any kind of elements. And then on the left-hand side are a bunch of multicolor examples of FR4. This is one of our first applications I'd like to discuss with you, knife handles and pistol grips. Especially for knife handles, colored FR4 is just exploding in the marketplace these days. There are literally hundreds of different versions of the FR4 that you can get. So my advice is if you have a knife handle manufacturer or a knife equipment manufacturer, go after those companies. Pistol grips, same type of thing, but not as prevalent, and that's kind of a limited market. You know, pistols aren't manufactured everywhere like it seems that knives are done. So G10 or FR4, what's the difference? Probably one of our most asked questions. That's why we dedicated a whole slide to it. FR4, as it sounds, flame retardant. It's got a chemical element called bromine, which is a halogen, and some other non-halogen materials, which makes it flame retardant. It's not fireproof, but flame retardant. It's got a UL rating of 94 VO. Plain G10, on the other hand, is not a flame retardant material. Has no flame retardant chemicals whatsoever in the formula. So it doesn't have that flame retardant capability. The big question we always get asked is, well, where can I substitute for FR4 and G10? Well, if you look here and you see the /27 for FR4 and the /2 for G10, if either of those materials are called out by that no spec number or the type, you can never, ever substitute. Somebody wants that /27 or they want that /2 for a particular reason. Most of the time, however, you can substitute FR4 for G10, but typically you can't go in the reverse. G11, basically G11 is a much stronger version of FR4 and G10. It's 50% structurally stronger, and the great advantage of G11 over G10 or FR4 is it goes up to 180 degrees C versus 140 degrees C. With those enhanced capabilities comes a little bit of a price increase. It's typically about twice as expensive as FR4. G7 glass silicone. This is a glass material made with silicone. It's our highest heat laminate. It goes up to 220 degrees or 428 F. This is typically used in high heat and arc resistant applications. And then on the on the right-hand side, the G7 is used extensively as a consumable in welding applications. So another application, if you have a welding equipment manufacturer nearby, I would look to them as possible for tube applications as well as G7 in general. G9, the glass melamine material. It's great for arc resistant and dielectric properties. It's also excellent in humid or moist environments. Another thing about G9 is it's an excellent substitute for G5. We don't really particularly carry G5, we can get it, but G9 is an exact substitute for G5. And then the final member of the glass family here is the G3 glass phenolic. This is typically used in aerospace applications, and it's really noted for its amber color, which is exemplified by the picture on the right-hand side of the screen there. It's got great compressive strength. You see 76,000 PSI. That is our strongest structural material that we carry. Temperature range is 140 degrees C, but it can spike up to 170 degrees for mechanical applications. And again, low moisture absorption on this product. So phenolic. There are three types of phenolic that we carry. Paper, the X, the double X, and the triple X. The linen, the L, and the LE. And then the canvas, the C, and the CE. A couple tips about these materials. The double X is our mechanical grade. The triple X is your electrical grade, and it's about 25 to 30% more expensive than your double X. The X actually comes in a couple of different grades. It's our lowest cost mechanical grade. There's also an XP, which stands for punching grade. So if you ever see XP, somebody's going to put in a die cutting press or something like that. Moving on to the linen, the LE, and the L, the C, and the CE. The E in both of those stands for electrical grade. Cost-wise, they're very similar. At one time, they were a little bit more costly between the two grades there, between LE and L regular, but now they're about the same. So these materials all kind of look alike here. How do you tell them apart? Well, it's pretty easy. If you go left to right, you have paper, then you have linen, and then canvas phenolic. The paper phenolic is characterized by the fact that there's no texture, has a smooth looking finish to it. The linen phenolic in the middle has a fine weave, and then if you look to the right, on the right hand side, canvas phenolic has a much coarser weave. So left to right, paper phenolic has no finish or no weave to it. Linen has a very fine weave, and then the canvas has a very coarse or rough weave to it. The typical color for all phenolic materials, the natural color is the brown that you see there. Black is available, but however, colors, unlike G10, are not typically available. They can be purchased, typically a very long lead time, and they're very expensive. So phenolic applications, I've broken them out into different types of applications here with paper, linen, and canvas phenolic applications. I would like to point out one in particular. You see the red there for die cutting. Again, another sales tip, if you have a die cutter nearby, they're probably using a very thin gauge phenolic or FR4, typically anything under 1/8 of an inch, and they're punching out washers and materials like that. So if you have a die cutter, I would definitely call on them and put them on your prospect list. So I mentioned they're probably punching out washers, but also gears are manufactured out of phenolic, terminal boards, and then also rollers. There's many, many applications for phenolic. So as we move on from just the types of materials there's three types of stock shapes that we carry: sheet, rod, and tube. And this is just a quick overview on the manufacturing of sheet. I'm not an expert in the manufacturing process, but essentially you take the pre-preg materials on the left-hand side there. It mixes with a resin, whether you're using like a melamine or a silicone or a glass epoxy. It's condensed under very high temperatures and high pressure, high heat, and then it goes through that molding process, and it goes from there. It's cut to size, inspected, packed, and shipped. It's pretty much high pressure, high heat, push down on this material. Our standard sheet sizes are 36 by 48. You'll notice anything that's highlighted in red has a 48 by 96, and coincidentally enough, the CE, the C, the LE, the L, the FR4, and G11, those are probably the 6 most popular materials that we carry. Thus, they have 4 by 8s. You'll never see 4 by 8s in G7 though. So an important word about surface finishes. We added this slide about 1.5 years, 2 years ago. We had numerous occasions where material comes out to somebody and it's scratched. Keep in mind, laminates are basically industrial materials. There are no NEMA call-outs for surface finish. So they can come with scratches and stuff like that. And 99% of the time, people don't care. They're going to machine these products anyways. If, however, you have an application that requires cosmetic appearance, it's best to let us know in advance, because we can save you a lot of time and effort by getting you material that's masked with either film or paper. And what that masking does, it eliminates most to nearly all of the scratches on there. And we've had numerous examples of this happening where customers complained about scratches. We've replaced it with the film mask material, and it's eliminated those problems. The downside is it adds a typical cost of 3 to 5%. And if we have to get it from the factory, it's going to be about 10 to 12 weeks. So a quick point about the sheet thickness tolerances of our material. Again, all of these the thickness tolerances are guided by NEMA, the National Electrical Manufacturers Association. So in this example, the tolerance for 1/8 inch FR4 on 125 thick is 0.12 or 12 thousandths. And what NEMA says is 90% of that sheet must be within 12 thousandths. NEMA also says that the other 10% can be 125% above that tolerance. So what does that mean? If you look at this example here, starting in the upper right-hand corner, this is an actual example here. This sheet measured out at 139, 118 in the bottom, 121, 120 in the center, and then 128 in the upper left-hand corner. You notice the one with the asterisk, that's actually outside of that plus or minus 10%. But keep in mind, so our materials per NEMA have a pretty wide open tolerance, kind of like acrylic, but they have some extra tolerances because of NEMA's 125% on another 10% of the sheet. A lot of numbers there, but keep in mind just that the tolerances can vary. So one way to eliminate the wide tolerance range there is through the sanding process. Our sanders can take a tolerance from plus or minus 12 thousandths and turn it down to plus or minus 3 thousandths, or plus or minus 5 thousandths on a full sheet that's a 48 by 96. And you can see from this left to right picture here, here's the initial pass. No, you notice the gloss on there is still intact. After one pass, you can see some of the gloss has been removed. And then on the right-hand side, after the final pass, all of the gloss has been removed. That particular piece is about 4 inches thick, but we can get that down to plus or minus 3 thousandths. And what that does for your machine shop customers is, rather than sitting there fly cutting or milling that down, we can sand that thing much faster than they can mill it down. And then a key point to remember, and we talked about some of the weights earlier, we can run a full sheet up to 2 inches thick and then 4 inches on cut pieces. There's just no way we can run a 2,000-pound slab of material through a sander. It's just not going to work. So rod. There's two types of rod out there. There's the molded rod, and then there's the sheet rod. The molded rod in the example here is basically the same type of process. You take that pre-preg material, the resin, the cloth, you wrap it around the mandrel, roll it up, and then prior to that heat and pressure process, you remove the mandrel, stick it in the press, and then crunch it down, and then grind it out at the end. That's how a simplified version of how molded rod's manufactured. Sheet rod, on the other hand, just like it sounds. We take a sheet of material, we'll cut it into strips, we break and turn the corners, and then we centerless grind it to some really nice tolerances. So you have molded and sheet rod. Again, how do you tell the difference on those? The molded rod on the left-hand side is what we like to characterize as a material that has a rolled up window shade look. It's got, if you look at this, if you roll up a window shade, it's going to have that rolled up look there. Sheet rod, on the other hand, is made from sheet, which is pressed flat down, so it's going to have that layer look across the whole thing. So if you take a material, turn it on its side, and it's got that rolled up window shade look, that's molded rod. If it's got the flat layers through it, that's sheet rod. Molded rod typically is 46 inches in length versus our 48 inches in length for sheet rod, so that's another way you can tell them apart. We only carry two molded rods, the linen, the L, and then the FR4 natural colors only. So that's another way of kind of differentiating it. The tolerances for both materials, molded and sheet rod, is very, very tight. We talked earlier about some of the wide open tolerances for sheet. But if you look, for example, on 5-inch diameter sheet rod or molded rod, the tolerance is plus or minus 5 thousandths coming right out of the factory. And then people always ask, well, where do I use molded rod, or where would that come into play? And typically, due to the way that's manufactured, due to its circumferential lamination pattern, molded rod is going to work best on a tubular part, where since it's compressed all around the diameter of that part, it's much stronger at every single point, whereas sheet rod is going to have two weak points on the left and the right-hand side. So molded rod works best for tubular applications, and then sheet rod is going to work for pretty much everything else. One aspect of molded rod, which is highlighted in the bottom left-hand corner, it's typically 30% more expensive than sheet rod. 95% of the market in the United States and Canada, and actually Mexico too, is sheet rod and versus molded rod. Again, part of that is cost, and we're making so much more sheet rod than molded rod that the cost is obviously going to be less. And yes, it comes in colors too. Multiple colors, standard 48-inch length, can be ground to any size diameter. If you have a specific color in mind, please check with us. If something's not there, we can probably get it planned. So tube. The tube is kind of manufactured in a very similar process to rod. You take that pre-preg and the resin material, wrap it around the mandrel, versus a sheet rod, versus a molded rod, you pull that mandrel out. It's actually stuck in the oven like that, and then once it's cured, it's pulled, that mandrel is pulled out. That gives you the ID and the OD, and then it's ground, trimmed, packed, and then shipped. Tube products come in all grades, materials, glass and phenolic. It's all made for custom order. There's standard lengths from 18 to 48 inches in length. One of the caveats about tube is anything with a wall thickness over ½ inch does have a tendency to crack. That's just due to the manufacturing process. And all the tube is certified to NEMA standards. So if you want G11 tube, we can get you G11 tube. If you want FR4 tube, we can get you FR4 tube. And I put together a bunch of applications for tube products divided out by electrical, sports and leisure, communications, and military and defense. So basically starting right there with the overhead lines, where FR4 is used for overhead line poles. Then you have metal detector shafts, which are made out of either carbon fiber or black FR4. Then kayak paddle shafts, which again, carbon fiber, black FR4. Down in the bottom right-hand corner, you have marine VHF antennas, which are made out of FR4 epoxy glass, which is painted white. Then moving to the left, you have antenna shrouds, which is epoxy glass painted UV stable. And as you move further on to the left there, you have antenna masts, again, made out of FR4. And then finally, paper phenolic, which is used in chaff flares or pyrotechnics. So there's a multitude of applications out there for tube products. And if you ever have any inclination to ask us where to help you out, we're more than glad to help you out and identify markets and stuff like that. So a quick materials review. Number one, there are 6 types of glass cloth: FR4, G10, G11, G9, G7, and G3. The MIL I24768 is the MIL spec that covers all materials, including phenolic, and they're both available in tube, sheet, and rod. 3 types of phenolic: canvas, linen, and paper. And remember, if you see an LE, that just stands for the electrical grade version of that. Number 3, shapes. 36 by 48 or 48 by 96 are the standard sizes. Molded rod or sheet rod is available up to 6 inches in diameter. And tube, there's pretty much, you combine the infinite sizes that are available with the grades, and they're just an infinite variety available. And then finally, stocking. Atlas Fiber, as I mentioned earlier, we do have the largest stock in the United States and North America. Most orders are shipped same day. We do accept blanket orders, of course, and we're very good with our quick order confirmations. So all these industries and all these materials, but what are thermosets used for? 99.9% of the time, and I used to say 100% of the time until somebody ordered a bunch of phenolic for shelves, but they're typically made into parts. Especially if an OEM customer is calling you up and they want some material, they want to buy a couple sheets of FR4 or phenolic, they're almost certainly going to fabricate it. You should always ask the customer, what are you going to do with this material? And this includes your plastic customers too. And what that means is if you're making machine parts out of laminate materials, like on the right-hand side here, that's a 1-inch thick part made out of FR4. It's approximately 7 or 8 inches long. And you have to ask yourself, would you rather sell 25 parts of that or sell 4 square feet of material for $120? You're definitely going to make a lot more money and profit margins selling parts than you are by selling just a few square feet of material. Atlas Fiber, we do have some very expensive machining for milling, turning, and routing. If you want us to quote our laminate parts, we're more than glad to do so. We have some very tight tolerances that we can hold on all of our materials. We can also cut the size sheet, and we can cut the size rod. And we can also sand materials, as we talked about. So again, I like to emphasize this. Look beyond just selling stock shapes. Machining, cutting, sanding, and fabrication add value. They add higher sales dollars and greater profit margins. So just a quick fabrication review. We do have CNC machining, 20+ mills, lathes, routers. We are ISO certified. We can do plastics. We can do thermosets. We can do metals. Number 2, cut the size. We have 5 CNC panel saws like that Holzman in the picture there. We have some pretty extensive cutting capabilities. Our cutting tolerances, we can get down to plus or minus 5 thousandths on our saws, or we can get down to plus or minus 1 thousandth on our routers. So very tight cutting tolerances. A lot of times we can ship those out same day, whether that be 1,000 pieces. 1,000 pieces, maybe a couple days. 1 piece we can probably get out the same day. And we can cut up to 6 inches thick FR4 or phenolic on our saws. Sanding, again, thickness tolerances up to plus or minus 3 thousandths. If you've got a big sheet of material and your machine shop's going to spend a lot of time fly cutting that material, again, sanding saves a lot of time and money for them. We could do in-between thicknesses, of course. Again, the maximum thickness on a full sheet is 2 inches. The one thing we can't do is once we get down to 028 thick, we can't sand that material. And again, just to repeat, largest stocking inventory in the United States. We're direct purchases from the factory. Kanban and other programs for stocking are available, and we will be glad to do blankets up for 1 year. If you have a customer that wants 6,000 sheets of a particular material and they're going to spread it out 500 per month, place a PO, we'll ship it to you or your customer direct, and we'll ship it every month so you don't have to keep that on your floor. And then a final review. Let me read the bottom point first here. Use Atlas Fiber as your resource center for joint sales calls, marketing tools, and other sales expertise. We will work with you to identify, qualify, and develop new customers. I always put this out there to our customers. If you want us to help you out, by identifying markets, get a hold of me, and we are more than glad to work with you. I will help qualify lists, and even do internet research and check out people's websites and identify where opportunities are available. So please take advantage of that. But these are what I consider the top 6 markets, starting the left-hand side, machine shops. To me, that's always been the easiest and fastest selling opportunity. You walk into a machine shop, and typically you're talking to either the owner or the decision makers right away. It's very easy to get in. And obviously, if a machine shop is using our materials, they are probably almost certainly using plastic materials as well. Then semiconductor applications, another great application for our material. Aerospace and defense, I can't tell you how many times I've seen our materials in tanks, missiles, aircraft, whatever. It's in that industry. Oil and gas. And I'll first state that oil and gas used to be really big with frac balls that were made out of FR4 a couple of years ago. That was a huge industry. Frac balls have completely moved on from FR4 and now are into other materials, but still the oil services industry still uses a lot of our material. Power generation, again, you're generating a lot of electricity, you're generating a lot of high heat, so our materials are huge in the power generation industry. If you've got a power generation company or a generator company or anybody generating a lot of electricity, the power companies, they are typically using our materials. And then again, electrical. Once again, electrical insulation, our products are used extensively as electrical insulators. So if you've got electrical equipment manufacturers, I would highly recommend calling them. But again, use us as your resource center. We want to work with you. We do want to make the joint sales calls. We want to help you develop the customers. You just have to ask us. And that concludes our presentation. I think I kept it around 30 minutes. And Courtney, if you want to open up to any questions, be glad to answer them. We do have our contact information there.
Thanks, Mark. As a reminder, please submit any questions using your webinar toolbar, and we already have one right off the bat. What are mandrels and molded rod made from? How are they made? And this person is asking because they seem to remain inside the molded rod.
Mandrels inside are typically they're made out of metal. I'm not sure what the metal is. Again, that's used in the manufacturing process for molded rod and also for tube. It's just the way that they, for the molded rod, for example, they wrap the resin around there, and then they put it in the press, and then they'll pull up the mandrel beforehand, and then I'll just crunch it down and make the rod that way.
Great, thanks. While we wait for additional questions, make sure to mark your calendars and join us this Friday for a webinar with IAPD's Contact on the Hill to learn how the implications of the stimulus package could impact your business. You'll get insights into the legislation and your question answered. So that's IAPD's webinar, COVID-19 in Your Business, What the Stimulus Package Means to You. And that will air live this Friday at 10 a.m. Central. Registration is now open. Perfect timing. We got another question. How much thickness does each pass on the sander remove?
It varies. We typically take just a small amount off there, just a couple thousandths at a time. And one thing we can't do, we cannot sand plastic. It just gums up the sander. So we can only sand thermoset materials.
We'll give it another minute as people may be entering their questions. Take this time to remind you that you will receive a survey about today's presentation. Once you complete the survey, there will be a link to download the presentation slides. You'll also receive a recording of today's webinar. All right, Mark. Oh, no, we got another question. Okay, let's see if you can answer this. How are the tariffs affecting the thermoset businesses?
Great question. Back in August of 2018, the government implemented a 25% tariff on Chinese materials. At that time, Atlas Fiber was bringing in some materials from China, not a huge amount, but it was a fair percentage. So we have moved away from Chinese material. We get a very, very small amount of material from China now, so it's not really affecting us. And with all the coronavirus situation going around, it's actually very fortuitous that we did move away from China because we weren't affected by any of the closures of the factories out there. So, I mean, it did affect us back in August of 2018, but the tariffs have pretty much not really affected us since then.
Great, thank you. Well, this concludes our presentation. Oh, go ahead.
I want to thank everybody for attending today, by the way. I know there's a lot of stuff going around and everybody's pretty busy, but do appreciate everybody taking 45 minutes to an hour out of their time today. Thank you.
Oh, Mark, we did have a question sneak in right while you were talking. Can you review the subject of UV resistivity? Did I understand correctly that this product has low UV resistance? Any thoughts on how long it is good in UV exposure?
Okay, we can put a UV coating on there. My email is mark@atlasfiber.com. Why don't you, whoever the particular person was that sent that, send me a direct question. I can answer that offline and get the particulars on what they're looking for, but we can definitely put a UV coating on there.
Okay. Well, thank you all once again for joining us. We look forward to hosting you again this Friday for our COVID-19 webinar. Have a great rest of your afternoon.
Thank you.